Hey guys, so we're going to start off with a little bell ringer, and it's just graphing lines. So remember y equals mx plus b. B is your y-intercept. Oops. And m is your slope. So we will read that as rise over run. So 3 over 1, up 3. 1, 2, 3 over 1. Oops. Up 1, 2, 3 over 1. And then we would connect, and mine's going to look really terrible, and I'm sorry, but there's your line that goes through it. Same thing here, y-intercept is 2. I'm trying to draw open circles because it doesn't let me fill them. And your slope is 1/2, so up 1 over 2. Up 1 over 2. Trying here. There we go. So a little review on how to graph. Ms. Blake, why do we need this? So we're going to move into, oops, there we go. Section 8.5, we're actually going to do systems of inequalities, and it involves some graphing. So to solve a system of linear inequalities, you're going to graph, right? And you want to be as accurate as possible when drawing these lines. Remember, if it's just greater than or just less than, you're going to have a dashed line. Or if it can equal, it'll be a solid line. And we'll shade the greater than, less than, all that good stuff. All right, so let's try some. So here, y is greater than negative x plus 4. So we're going to graph negative x plus 4. So we're going to go up 4. And then this is technically a slope of negative 1 over 1. So that means down 1, right 1, down 1, right 1. Or you could go up 1, left 1. Either way, that'll still be negative. All right. Oh, just kidding. I'm already messing up here. So this is just greater than, which means we're going to use a dashed line. So we're here. All right, so it's a dashed line because it is just greater than. And then we're going to shade. So notice it would fall this way. That means everything's less than. This is less than. Y is greater than would be shading above. So we're going to shade all of this. And we're going to pretend this is shading because you can't really color on this thing. All right, so that's the graph of the first one. Now we're going to graph the second one. I'm going to go ahead and use a different color. So how about red? So your intercept is 2. And then your slope is 2 over 5. So up 2 over 1, 2, 3, 4, 5. Or you could have gone down and left because negative makes positive. So 1, 2, 1, 2, 3, 4, 5. Again, there's no equal sign, so it's going to be a dotted line, dashed. Mine is super wiggly because it's hard to write on this, but you get the gist. Now this says y is less than, so we want everything below this line. And you might say, Ms. Blake, what's the solution, right? What's the solution to this set? Well, it's everything that's the overlap. So I'm going to actually use green. Do you see where these two colors are overlapping? This is your solution set. That is your solution set. Now it says check your solution. So check your solution just means pick a point in your solution set. So you can pick any point in here. And this is why I said be careful with graphing. Make sure you graph, on a coordinate plane, on graph paper. Because you really want to pick a point that's definitely in here. So what about 5, 2? All right, 5, 2 is definitely in here. 5, 2. So let's plug this in. And I was strategic about the 5, 2, by the way, because I saw that fraction. So I know the 5s will cancel out for me. There is a reason I chose it, but be strategic. Even if you're not, you'll still be fine. Any point in here should work. So it says y is greater than, so 2 is greater than negative x, so negative 5 plus 4. So 2 is greater than negative 5 plus 4 is negative 1. 2 is greater than negative 1. That works. And then you have to plug it in the second one as well. So we have y2 is less than 2/5 x, which was 5, plus 2. Again, smart point picking. Smart point picking. So those 5s will cancel. We have 2 plus 2. So 2 is less than 4. Again, that is a true statement. So you want to make sure that, you know, in your solution set, whatever you say is your solution set, that the number actually works. So pick something in there. Again, our solution is the green. So everything here is your solution. Will work in these two equations, or inequality, sorry. Let's try another one. Uh-oh. So if you notice, you don't have that y equals mx plus b form. So make it happen. Add 3x to both sides. So we have y is less than or equal to 3x minus 1. And now it looks good. Here we're going to divide everything by 2. So we have y is greater than or equal to 4x minus 3. And again, now you're good. Now you can graph. So we're going to go minus 1. And then our slope is 3 over 1. So up 1, 2, 3 over 1. Up 1, 2, 3 over 1. And there's an equal sign. So this is now a solid line. I would do so much better if I had a ruler on here. Now we're reading y is everything less than, so we want below. Alright, we want below. So everything less than. I'm going to switch colors. Go red again. So we have negative 3, and then our slope is 4 over 1, so up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. This is going to be terrible. 1, 2, 3, 4 over 1. I'm trying here. Oh, and solid line because it's equal. There we go. And we want everything greater than. Everything greater than. So we're going above this line. So we're here, here, here. Everything above this line. So it's kind of hard to see quite where they're overlapping, especially in my picture. But it looks like this is where my colors overlap. This is where my colors overlap, in between. So let's pick a point and check our solution. So I'm going to pick the point 0, negative 2. So 0, negative 2 is definitely in my green there. Again, you get to pick a point. Pick a point somewhere in your solution set and plug it in. Alright, so we got y is less than or equal to 3 times x minus 1. Negative 2 is less than or equal to 0 minus 1 is negative 1. So negative 2 is less than or equal to negative 1. That works. And then y is greater than or equal to 4 times x minus 3. I'm just plugging into the second one. So we have negative 2, is greater than or equal to 0 minus 3 is negative 3. Negative 2 is greater than or equal to negative 3? Absolutely. So we just plugged in something and checked. Now, if you mess up on your shading, you should find out here where you messed up. So notice the second equation is already set to go, but the first equation is a little bit harder. So again, we want to get y alone, so we're going to subtract 3x. So we got 4y is greater than or equal to. We're subtracting 3x. We still have a minus 12 over here. And then we're going to divide by 4. So we have negative 3/4 x. And then negative 12 divided by 4 is negative 3. And now we have our two equations. So let's graph the first one. We have negative 3 and then negative 3/4. So down 1, 2, 3 over 1, 2, 3, 4. Or you could have gone up and left. Either way, it'll be negative. Up 1, 2, 3 is positive. Left 1, 2, 3, 4 would be negative. Positive, negative makes negative. Equal sign means solid. I missed. Don't judge me. There we go. And we want y to be greater than, so we're shading up. Right? Everything above greater than. All right, you get the gist. Let's switch colors. So we got a positive 1, and our slope is negative 1/4. So you can go down and right to get negative, right? Negative, positive. Or you could go up and left, positive, negative, doesn't matter. So down 1 over 1, 2, 3, 4. Or you could go up 1 over 1, 2, 3, 4. Up 1 over 1, 2, 3, 4. Now here you want y to be less than. So there's no equal sign, we got dotted lines. This is harder than it looks. Okay, there we go. So y is less than, we want everything below. Everything below. So we got quite a large overlap here. Looks like everything in between those two. All right, everything in green. There's your solution set. I see one that sticks out to me. 0, 0 is in there. So I'm going to grab 0, 0. We love when 0, 0 is one that we can check. So let's plug it into the first one. 0 is greater than or equal to negative 3/4 times 0 minus 3. So 0 is greater than or equal to 0 minus 3, which is negative 3. 0 is definitely greater than or equal to negative 3. The second one, oops, y, 0 is less than negative 1/4 times 0 plus 1. So we have 0 is less than 0 plus 1 is 1. Right, or 1 is greater than 0, either way, correct. So we checked our solution. We found a point in here, and we plugged it in. Again, be smart about your point picking. That's about all I got on that one. Be smart on your point picking. We have a couple more, and I'm not going to have time in this video, so I am going to have a part 2. I will come back on example 4.